Hello, in this video I'm going to show you how using the CPL on Broadcom ProxySG you could write some DLP rules. So here on the screen you can see the ProxySG content policy language guide and the code that we're going to be working with is the http.request.data. So ProxySG is capable to inspect the HTTP payloads of up to 65,000 bytes in size. If you want to inspect, of course, HTTP payloads that are sent over a SSL or TLS socket, you have to make sure that you protocol detect first of all the traffic and then SSL intercept it. So you basically do the man in the middle on the proxy to decrypt it to see the payload. If you don't do that, then the proxy is not going to see the HTTP payload and this policy is not going to work. So the syntax that we're going to use here is this, and then you can specify the number of the bytes that you would like to inspect. If you don't specify the number of the bytes, then the default the maximum is assumed here, right? And then you're going to choose one of these criterias to tell the proxy what you're looking for. So it's 4 types of strings. So the first 2 are string types, matches, and the last 2 are string type, matches, and the one in the middle uses regex. One thing to notice here, while the proxy is perfectly capable to inspect every single payload, this could have quite a high CPU impact, depending how hot that box is, how many users you have there, how many requests you are sending. So usually this gets to use in reverse proxy environments where you just protect a server farm or a few different servers rather than a forward proxy, whether that's a transparent proxy or explicit proxy, mainly because of the number of requests that proxy is there to serve. So in a demo that I'm going to do, I'm going to be using the substring matching criteria on my transaction. So I'm going to jump here into the policy. I am using management center, but you can use you can edit directly the local file, any tenant files, the central file or the forward file directly on the ProxySG. Here is the rule: HTTP request data. I am telling it to go to inspect the full the supported size, which is 65,000. I'm using substring and I'm looking for this string of confidential. So the actual business case here, I guess, is we want to be able to block uploads of HTTP payloads by the users where it contains a specific string. So in a real world scenario, this could be some PII information. I don't know, it could be national insurance numbers, contact details, emails, names, or credit card numbers, and so on. So I'm just going with a string of confidential, and we're going to force deny this to make sure that nothing else can overwrite it later on in a policy, because we didn't specify the exception. The default exception page for that is going to be used, which is the policy_denied. I show you that here. That's this guy here. This is the exception page that the user is going to get. However, for the purposes of the demo, and a lot of customers do this in real world as well, you probably want to customize this. So it kind of gives the user a little bit more information, and it gives a little bit more information to the IT person who is troubleshooting the issue. So I am going to add this string here, this paragraph, into that HTML code that says you try to exfiltrate confidential data. So we know that we get blocked, and we will have the reason why we got blocked. In fact, what we can do here, we can do something like this: reason, you try to exfiltrate confidential data, I'm going to push that into the local file on my proxy. And then let's get on with the test. So here I have got, let's get the PCAP running. I have got 2 tests. First one's going to be over SSL TLS, so I'm using Python. I connected the proxy explicitly, so this is a forward proxy environment, it's not a reverse proxy. I've got this 517 characters or bytes long string here, or HTTP payload, and here towards the end I've got this string confidential. That's the one that we are looking for. And just for the purposes of me being able to see the string better and see it better in a pickup, I kind of wrapped it around with these stars. And because we are posting, here is our method for the TCP socket, right? For the upload, we have to of course include the content type and the content length, otherwise the proxy will refuse that with 400 invalid requests. So we have to make sure we follow the RFCs, and we create a socket, we connect to the proxy, so this is the TCP handshake done at this point. We then send the connect to the proxy. It doesn't matter what host I'm going here because we know I'm going to get forced in anyway, so I could put absolutely anything here. And then we're going to put the response we got from proxy in a variable, and we print it into the screen so we know what's happening. At this point, once the connect is done, we can wrap the TCP socket in SSL handshake using the default context. And this will complete the SSL handshake, and at that point we're going to be sending the post, which is these headers and this payload. And we got a little while loop here. We're gonna get up to 4096 bytes and store it in this variable. In this demo, this is more than enough because all I'm going to get back is the exception page. And we sort of print it on the screen here. So what will be printed here is going to be the exception page. And that's it. We close the socket. So I'm going to one more thing to do before I do this. Let's wipe the trace. So a new trace. Let's run it. And here we go. So first of all, here I printed this response to the connect. We got 200 OK connection established. What I got then is 403 forbidden, and here are the headers, and here is the body. Here is the payload. Right? We got blocked, policy denied. This is the exception, right? Policy _ denied. Here is our string reason. You are trying to exfiltrate confidential data. And we also confirm the same in a pickup, right? So there is our TCP handshake, there is the connect, 200 OK from the proxy, start of SSL handshake with client hello, server hello, handshake done. Here I'm sending the post, and here I got denied, just to show you where. So here is the form. This is the data. This is our offending string. Unfortunately, it's truncated, so we don't see it. Yep, we don't get to see it here. But we did get 403 back, and here is the body of the exception page. Again, we see the string here. If I now go into the policy trace, do refresh here, we get to see that we get to see three transactions. We got the connect that hit the proxy because I'm explicit. I didn't match my block here, of course, because there's no payload. Because protocol detection is enabled on the explicit HTTP proxy service, that transaction got detected as SSL and handed over to SSL. So that's the second transaction here. Again, I didn't get blocked because this is just the internal handoff, right, from HTTP explicit proxy to SSL proxy. And because SSL interception is enabled, but sadly I'm not tracing on SSL intercept layer, so you don't see that here, we end up getting the third transaction finally, which is the HTTPS transaction here. Here is the post. Here is the 403 deny I got back. Here is the rule that we matched, right? There is the request confidential false deny with a string of reason you try to exfiltrate confidential data. Let's do one more test. I'm going to wipe this. I am going to restart this, and let's run one more test, just one HTTP. So let's run this guy again. This time we didn't get, of course, the first 200 OK because there's no connect, right? There's no SSL. We didn't have to wrap this TCP socket with SSL handshake. It's just, we create a socket, we connect to that socket, and we send these headers with this payload over. So if I go here, we can see that, right? There is the TCP socket done. Here is the post, here is the data, and this time we can see it here in plain text. Confidential, there is our string right here. Again, it's truncated here, so we don't see it in the left pane, but we see it here on the right. And what we go back is the forbidden. I just wonder if I follow the stream whether that's going to show me the payload. Is it? Yeah, it's not truncated here, so there you go. So here we have posted the headers, here we have posted the payload, and here we have received a response from the proxy. And there is the exception page. Again, we know that we matched the right rule because it's the only rule where we are adding the string. And we can of course confirm that with the policy trace. This time we got only one because it's HTTP. There is the post, and there is the rule. So yeah, you could very easily sort of expand this simple idea into something more, where you could write your own lists of strings inside the CPL code or using regexes, and then use this operation in CPL to deny those requests. And that concludes the demo. Thank you.